Good evening to everybody. And from listening to you guys talk prior to the meeting, it sounds like a number of you have been on the VHF band this past weekend. Um, it sounds like you had very good conditions out there in the Midwest, um, and you even had 2 meter openings. That's pretty good. That means the MUF got pretty high with sporadic-e propagation there. Here in the East Coast, we did okay. We had some marginal sporadic-e opening. We usually go QRP portable on a hill about 5 or 6 miles from here. You guys out in the Midwest are lucky because you have some big hills and mountains. In Long Island, the tallest hill is 250 feet. So that's the way it is. It works out though because we get some good tropo here. But Long Island is it's basically made many years ago by the glaciers, so there really weren't any mountains, just a lot of mounds. So 250 feet is a mountain on Long Island. So first, we'll go to the next page on the slide there, please. Okay, so that's a picture of me. That was a talk I did about 15 years ago on 6 meters. And as mentioned before, I've written for CQ VHF on when it was a quarterly and also when it was a monthly. That has passed, but I was fortunate to hook up with Worldradio to put together a book on 6 meters. It first came out in 1994, and the last edition came out in 2008. That was the 4th edition. In addition, I teamed up with Gordon West, who's here tonight, WB2AMU. We co-wrote a book called VHF Propagation, a Practical Guide, and that was written for CQ Magazine back in 2004, 2005 timeframe. And it has just been revised this year and updated. We now have a chapter on FT8, which wouldn't have been in the first edition. And it was written by, that chapter was written by Chip Margelli, K7JA, and unfortunately he passed away recently. But we have his insights on FT8. So those are the 2 books we've written. Basis of many experience. You notice the VHF propagation book has a green Aurora on the cover, so we thought that photo was taken by Chip K7JA. So very, very important. Next slide, please. So you guys may have heard the term magic band for referring to 6 meters. That phrase may have been coined more than 30 or 40 years ago. And the reason why it's called the magic band is because most of the time it's very, very quiet. And there are certain times during the year where it's like absolutely dead. But when you have propagation modes show up, like Sporadic-e, Aurora, F2, TEP, or combination modes, it really springs to life. And it's very easy to hear these modes, and generally you can identify what kind of propagation mode is involved because the band is generally very quiet, and you can figure out based on distance and other things what propagation mode is involved there. Next slide, please. So I'm going to start a little bit on what F2 will be like. We'll have a chart where the F2 activity is now. About 5 years ago, they predicted cycle 25 would be horrible, even worse than cycle 24, which was pretty bad. And there's so much we don't know about the sun and other natural phenomena. And so far, it looks like cycle 25 is doing pretty good. And I'm guessing the peak will be sometime next year. So this fall may be pretty good for 6-meter propagation. There will probably be TEP paths, which will be things like Argentina into the southern U.S., like Texas and Florida. And there are also links, Sporadic-e links for these paths too. So states in the upper part of the U.S. can connect to that. And I'll show you that in a chart later on. However, the main bread and butter mode will be Sporadic-e, which during the summer goes from May through early August. So just based on what I'm hearing with the contest this last weekend, sounds like we had pretty good Sporadic-e activity, and it even reached up to 2 meters. So that's pretty good. Next slide, please. So here's cycle 25 up to about last week. And you see that little green circle where we are. And already it looks like it's going to project to be much better than cycle 24, the previous cycle. I'm saying it's probably got a good chance to reach cycle 23. Sometimes there may be a very good upward path of, solar flux / sunspot numbers, but it's all of a sudden the sun just, kind of drops out. But I'm pretty optimistic this will be a decent cycle.
It's Lobster and Shrimp Tacos Tuesday.
Hello? Okay. So I'm pretty optimistic this will be at least better than cycle 24, maybe the equal cycle 23. So this plot came from website is Northwest Records there. Next slide, please. So we'll talk about Sporadic-e first. And like I said, F2 is probably going to be reasonable to cycle, but we still have Sporadic-e, and we're right now in the heart of the Sporadic-e season in the United States. It's a skywave propagation mode, and it goes from May through August, and it certainly makes the band interesting. Sporadic-e, you can actually work on other bands like 10 meters. I do the 10-meter contest in December every year, and the last 2 years we had some pretty good Sporadic-e openings on 10 meters, and so it's not just 6 meters, but it's on 6 that it gets to be very interesting, because 6 meters is a borderline band between HF and VHF, so the band gets very exciting. Next slide, please. So, believe it or not, Sporadic-e was discovered by radio amateurs in the United States in 1935 on the 5-meter band. That was 56 megahertz. That was assigned to hams prior to World War II. Formations are basically thin metallic ion layers that are 100 kilometers up at 70 miles above the Earth in the E region of the ionosphere. As I said, you can hear it on 28 megahertz at 10 meters, and on many occasions it goes to 6, and on rare occasion 2 meters. And there has been some incidents of 220 megahertz contacts made during a contest. So it can really cover a lot of distance, but those are rare. 28 and 50 are going to be your main frequencies. As I've listed here, formations last for as little as 5 minutes to as much as several hours. And because it's a very dynamic formation, removing particles, it can be subject to fading. But then if you just hang around, signals can come back up. The major season is from May to June, and there's a minor winter season from November to January. Next slide, please. Okay. Through research in the 1960s and 70s, they have sent rockets, probes into active sporadic-e layers, and they have found that the metallic ions are usually iron, magnesium, nickel, silicon, and other metals. They've done this from places like Wallop Islands and a few other locations in the United States. So the metal that's in these formations are believed to originally come from meteor ablation, when meteors enter the ionosphere and burn up into small particles. The reason why the summer season is very significant is because these metallic ions or particles combine with oxygen ions in the E region, with solar radiation being strongest in the summer month. And what's cool about the summer season is that you may have multiple sporadic-e formations occurring at the same time. And this can give you long-range 6-meter contacts, sometimes 2, sometimes 3, skips, involved. And, it's not difficult to work into Europe and from the East Coast, or work transcontinental from the East Coast to the West Coast. Now, here's the interesting thing about sporadic-e. When formations get denser, higher frequencies can be reflected. So at this point, the skip appears shorter in distance on, say, like 6 meters. When it goes under 800 miles, it pays to listen on 2 meters because the way it works out by formula. You can think of it like a sponge. If you have an old wash sponge that's soft, you can squeeze on it. That's almost like the effect of a sporadic-e layer being compressed and being able to reflect higher frequencies. Big important fact is sporadic-e is basically independent of the solar cycle. There's little variation year to year of the solar cycle. There may be some impact from geomagnetic events, but in general, sporadic-e is reasonably consistent during the summer months in the United States. Next slide, please. Here's a very simple graph of the single hop sporadic-e propagation path here. Basically, skywave across. Doesn't really matter if you're horizontal or vertical, although a beam gives you more punch in one direction. And so a single hop would be about 700 to 1200 miles. And you can work any of the modes, sideband, CW, AM, FM, and FT8. I have made a couple of AM contacts in the past on 50.4. Next slide, please. Okay, on this chart, I've used this basic map for all my talks, so I have to move that circle for each talk. So this one I put in Wisconsin, since the majority of people are from this area. So that's a general idea how far you can reach from Wisconsin into surrounding areas in the United States. So Wisconsin to Long Island is a very typical path, not uncommon at all. Next, this would be a very simple graph representation of double hop sporadic-e. It's probably a little bit different in this, but basically in between formations, you may go down to Earth or something in between, but that's a very rough graphical representation. Next slide, please. Okay, so now instead of the single hop from Wisconsin, it goes another 800 to 1,000 miles beyond that range. So from Wisconsin, you'll be able to work the West Coast like California, Oregon, and Washington. and other parts. So that's a rough representation of how far you can work. Next slide, please. I'm looking at here, 6 meters has changed in the last 5 years with the influx of digital modes. So you'll see a lot of people trying it out. That's not a mode I do at all. I've seen it demonstrated, but you know, I'm still a sideband CW guy. The thing to keep in mind that the beacons are still present on 6 meters between 50.060 and 50.080. So that's a good indication if you don't have a computer in front of you or a chat page. You can still listen for these beacons, and most of them are typically 5 watts to 20 watts power range, and simple antennas like a vertical or omni or even a halo. As evident by this past contest, sideband and CW are still widely used, particularly when you're walking between bands or, you know, spotting for someone, but is still used, and you can do better QSO rates on sideband when the band is really red hot. It generally takes a little longer to complete a digital contact, but the software continues to be improved, and so each new version they work out certain bugs regarding speed there. Next slide, please. Multiple hop 6 meter Sporadic-e. As I mentioned, some of your DX modes become available. June and July is statistically the best month for multiple hop formation. Very, very active in the E region there with the Sporadic-e particles. And during June and July, eastern parts of US can work into Europe, generally Western Europe like Spain and Portugal. And Western and Midwest states can generally work into Hawaii and Japan in the other direction. There's no magic formula, but typically we can see 5 to 6 transatlantic openings between the east coast of US/Canada into Europe there. As I said, it's not affected by the solar cycle, so it's generally consistent each summer. And you can do well with moderate equipment, simple 3-element beams like a Cushcraft, and 100 watts would do pretty good. Next slide, please. Here's a opening I experienced, one of the better openings I experienced in the last 20 years. I worked all these stations from just after noontime here into the early evening. And, you know, as I mentioned, Western Europe and Portugal was the 2-hop range, and the 3-hop range was a little further in, like England, Northern Ireland, Netherlands, and the 4-hop range into Eastern Europe, like Slovenia and Croatia. So that was a pretty good opening. Next slide, please. And here's the details that opened. So after the European opening, we also had a nice opening to the West Coast. And so I worked 2-hop into Mexico, New Mexico and Arizona, and even into British Columbia and Idaho. So I'm guessing, you know, as a rough guess, and I could probably plot this, there was at least 5 or 6 individual Sporadic-e formations at one time that were in play. So that was a very good day. I still look at that logbook page periodically to remind me of it. Next page. A couple years ago, we had a very good summer, and I just broke it down here. I had at least about 10 openings that went in across the Atlantic, mostly Western Europe, even in northern part like Sweden and Finland. So they were coming in, and then into the southern more in the southern route there, to Spain and Portugal and the Canary Islands. There's some very, very active stations there in the Canary Islands. So that was a pretty good summer, and these were all on CW and sideband. On FT8, it's there is also quite a bit to be worked. Next slide, please. So what does Sporadic-e formation look like? Well, this is an iSCAT radar plot from Europe, a guy from another scientist there, and you can see that the Sporadic-e formation in terms of thickness is very thin. It's only about 10, 20 not kilometers, meters in thickness. So it is truly a thin layer that's compressed by the winds in the ionosphere in the E region there. So you have winds from different directions just compressing these particles into a formation by wind shear. The method is wind shear. So next slide, please. So, of course, Sporadic-e, it's very interesting. A lot of debate on what causes it. For a long time, a lot of people believe that thunderstorms were part of a mechanism. But you got to realize thunderstorm activity is around 10 kilometers. Sporadic-e occurs at 100 kilometers. So if there's any relationship, it's maybe indirect at best. Basically, the oxygen ions at 90 kilometers recombine with the neutral metal particles to form metal ions that make the basis of a Sporadic-e formation. And as I mentioned before, with more solar radiation in the summer, you have more oxygen ions in the 90-kilometer range, and that combines with the metallic particles. And wind shear is a major part of these formation of these layers, and it is random. It's almost like if you look at a swimming pool and you see all the particles collect in the middle of the pool in a circular pool. And part of the equation is you have tidal waves pushing down on it. So eventually these formations will break up with some of the particles going down to Earth. Now, you have to visualize Sporadic-e is like an invisible mirror in the E region. You can't see this, but it's there. And so that's a way to visualize it. Next slide, please. Here's a theory. It's not a perfect theory, but it shows in number one there that you have solar radiation working on metallic particles, and you have some particles recombine, and then they're affected by wind, as in box 5, and then some particles do not recombine and they just drop out and go to Earth. This is a very rough theory. It's probably a little bit more complex than that, but this is a little bit easier to visualize and explain to people. Next slide, please. FT8 has been an interesting development for 6 meters. Prior to 2015, sideband and CW weak signal modes were the major activity for DXing on 6. FT8 was invented by Joe Taylor and Mr. Frankie, and the beauty about FT8, you don't need a superstation to work stations, and it hears signals below human hearing. So the computer does the work. The computer is the means to hear signals, and I think of it as a very good way to study propagation, in addition to the existing means we have, like ham radio observations and digital ion sounds at different locations around the US and the world. One thing that it has shown is it confirms that there are very little Sporadic-e during the spring and fall equinox period. There are some limitations with FT8 on 6 meters, but as I've said before, they're working on improving it, make it faster. Right now, you can still do a string of sideband much faster than you can do FT8. I guess a very good sideband station during a contest can do 3 to 4 sideband QSOs a minute. I think FT8 is probably about 1 or 2 a minute. So, but that gap will probably get smaller as they continue to develop the software. Next slide, please. So, as I mentioned before, the wind shear is a critical component for formation of sporadic-e layers. They're not uniform in the E region, so sometimes you get very non-uniform wind patterns, and these particles collect almost like in a vortex where things slow down and formations are developed. So, you know, they form to a point they can reflect radio waves, and at some point they break up. They have a limited life. How long, nobody knows until we work them. Next slide, please. I'm going to talk a little bit about Aurora. I usually have a tape, but Aurora is a very interesting mode. There wasn't a lot in the last cycle, cycle 24, but previous cycles, I could actually work stations using 10 watts and a dipole on Aurora. Now, if you ever heard Aurora and you hear it sometimes on 10 meters, but on 6, it sounds like somebody talking with water in their mouth, like they're gargling. CW is a very good mode for Aurora because you can handle the distortion. And I have worked stations on 2-meter Aurora, but the signals are so wide, it has to be on CW. You can't do it on sideband. As far as I know, I do not think FT8 is an easy mode to use Aurora, so CW continues to be the best mode to work Aurora. Aurora comes up when there's high levels of geomagnetic activity in the E region, and sometimes you have a CME impact or some solar event coming from the sun that hits the Earth's magnetic field, and a couple days later you have Aurora activity. Next slide, please. So what's interesting about Aurora is a backscatter mode. So you can work stations typically by pointing your beam antennas to the north, stations in the United States, because the Aurora has been extended from the north there, from Canada, and your signal comes back off of that formation and you work your stations. I'm going to give you a funny story right now. So 2 cycles ago was pretty good, cycle 23. I once had an Aurora opening in the middle of the day at my work location in Hauppauge, Long Island. And I heard a local station that was about 10 miles to the west of me. So I could kind of hear him, you know, by direct ground path, but I told him to point his antenna north, and I did the same. And we were working each other by Aurora. That's how far down it went. It was the funniest thing. So we could either work each other direct, or we could work them by Aurora, and we were, of course, distorted. But I thought that was funny, you know, someone 10 miles away, and I'm pointing my antenna to hit the edge of Aurora formation about 150, 200 miles away. So that was quite an unusual event there. Next slide, please. Another mode on 6, which we're seeing more of now, is trans-equatorial propagation. And the F layer over the geomagnetic equator is generally very easy to charge up during moderate solar cycle. Prevalent during the equinox period, so April, May, October, November. You don't need as much ionization as you would need for regular F2 contacts. Generally occurs late afternoon, early evening, and I will show you a plot in the next slide, please. Yeah, so that's kind of how it works. So a station in Argentina, say in the south, um, will have a signal go up into this F layer, which acts like a channel for several hundred, close to, well, actually thousands of miles. And it exits out, and you get into the southern United States, like Florida typically. Don't need a lot of power. Signals can be a little bit distorted at time. And as I mentioned, it's a late afternoon effect. I have heard it when I visited Florida once. I actually heard the signals come in. Now, just because it goes into Florida, people in the northern part of the U.S. are not left out. Next slide, please. Because certain times you can have a sporadic-e link, say from where you're located into the Florida area, and it hooks up with the trans-equatorial propagation. This is one of the beauties about 6 meters, is the fact, because it's generally quiet, when you work a station, like say from my area, Long Island, or say from your area, Wisconsin, into Argentina, this is the only pattern or mathematical explanation for it. And I have worked a few by this mode. Sporadic-e is not too consistent during November and October, but if you have an active TEP event going and you happen to have a sporadic-e event, this is how it can happen. So another interesting thing about 6 meters there. Next slide, please. Here's an interesting opening. I worked 8 years ago. This happened late in the afternoon, and I worked 3 stations in South America by TEP plus a sporadic-e link. I worked a station in Chile, Argentina, and Uruguay. Now, the interesting thing is, this was in May of 2014. A month later, I was giving a talk at the Aurora convention up in Hartford, and I met the station from Chile, CE3SX. He attended my talk, and so I had an eyeball QSO a month later. So that was pretty interesting. So TEP is a very good mode for 6 meters. So next slide, please. So as I mentioned, primary modes are sideband, CW, and digital modes. FM was a moderately popular mode on 6 on 52525 megahertz. This is simplex frequencies, and there are some areas of the country that have some repeaters on 6 meters. But recent years, digital modes have been kind of moving towards the front as far as daily activity goes. But the one thing is, the contests, you hear all of them. So you can still do sideband and CW. You can select the category that you prefer and enter it that way. So I usually do QRP portable, weak signal with CW and sideband and FM. So that's how I usually do it. Next slide, please. So as I mentioned, the digital modes were developed by Joe Taylor and Steve Franke. They knew that sporadic-e can sometimes be very weak, so this was a mode they thought would help. So it's a very useful tool for propagation studies, but it's essentially 2 computers working each other. I don't know, but some people have told me you don't even have to be in the room when this happens. So you guys might know, I don't. But at about -3 dB, you can almost hear signals. But below that, it's FT8 is the effective mode. But when it gets to -3 dB, it almost makes sense to go CW and sideband and use those modes. And so FT8 is good. The only problem, if you're walking the bands, like 6 meters, 2 meters, 220 or 432, it's a lot easier doing it with a weak signal mode like CW or sideband. Next slide, please. Beauty about 6, you can use pretty reasonably simple antenna setups, and portable operations easy. Those are pictures of my 6-meter Yagi. This one was made by MFJ. The one picture on the left is a field day site in eastern Long Island in the North Fork, and that's up about 15 feet. And 1998, we had a very good field day. We made over 270 contacts on 6 meters during a 24-hour period. We even beat the 80-meter station, so I thought that was terrific. On the right is a 3-element Yagi. It's by the hill I mentioned before on Long Island, 250 feet up. And it's very effective, relatively simple. I agree it's not optimal, but it does okay. Next slide, please. There are VHF contests, and this is a good way to get started in some fashion or another, whether it's your home station or you do QRP, portable or mobile or rover. There are many different ways. There's 3 contests by the ARL. We just had one in June. They will have one in September on the second weekend in September. January is typically the second or third weekend. And there's a CQ Worldwide VHF contest that occurs in July, which is 6 meters and 2 meters only. So that's a good time to do some operating, see what limits you have with your setup. Next slide, please. Tips on working DX. This is all the important frequencies. So 50.125 is the domestic call-in frequency. 50.110 is the DX call-in frequency. As I mentioned before, there's a beacon portion from 50.060 to 080 for all the CW beacons. The digital modes are on 313 and 323. That's where all of them hang out. CW is still very important. There are a number of European stations that still prefer the CW mode, and that's typically where they kind of hang out between 080 and 105 in that range. There's a website which is a spotting site, ON4KST. There's a lot of chatter going on. Nowadays, I would say 80% of it is FT8 oriented. F2 is not quite started yet, but you're going to have all kinds of fun, when cycle 25 gets going, and you still will have the summertime Sporadic-e season. Next slide, please. So here is my book that I wrote on 6 meters. This is the 4th edition. I still have quite a few number of copies. It's out of print, but when Worldradio closed up, I was able to get the remaining copies. And if any of you are interested in getting a signed, personalized copy, you can send me an email request as listed below, ken.neubeck@gmail.com, or it's on QRZ also. And I sell them for $10 each and $5 to cover the shipping. It may be slightly dated because, as I mentioned, the last version was written in 2008, and FT8 came in full force around 2015. So this is still, doesn't have a lot of digital information there, but it covers the propagation modes that I discussed. There's a whole section on the old 6-meter radios, like the Gonset, and a lot of the radios that came out, the Night Kit. So, and some of the interesting antennas that came out, like the Squalo and the, all those type of antennas they used to make. I think there might be one more slide, maybe not. This might be it. No, that was it. So I know there must be some questions, so I guess we'll just open it up for questions then.
Yeah, any questions? And by the way, Ken, just a fantastic and very, very timely presentation for all of us. So thank you very much. I have one of your, I'm not sure which edition it was of your book, a lot of good information. And yeah, it may not have the latest digital, but all the fundamental information is, in theory, is there. So that's a great resource. So questions for Ken?
I'll just make one. I was active during the VHF contest this past weekend, and I operated some of the FT8, and I also noticed some FT4. FT4 is a way of doubling the speed of contacts in a contest. I think that the contest committee really should ban FT8. It's great for DXing, but FT4 would be much more efficient in a contest, a VHF contest.
Yes, I had seen that. I think it's the contest committee has a lot of work to go through and sorting out this. Do you make it like it is now, where you have different categories and have all modes available, or do you make it just like weak signal modes one weekend and another weekend will be digital modes? I will tell you, it's a little frustrating sometimes when I'm on like 2 meters and I can work like 3 or 4 stations by sideband, but then I hear the digital noise on 144, was it 174? And you would say, hey, you know, why don't you move off and see what's out there in the other modes? But I think they got a lot of work on hand to sort this out, because the technology has really pushed this, you know, to a different state than where we were, you know, 5 years ago. So, but I think, yeah, I think that will be one thing they're going to definitely have to consider is FT8 versus FT4. And if they agree on what's the mode to use, that will make things a lot better. Okay.
Ken,
Next
you made a comment a few minutes ago about the possibility of unintended operation of the digital modes. And there is hacked software out there that allows the computer to, you know, call CQ and answer people, and then go back to calling CQ again. And that is not the normal WSJT or the other digital suites. That's hacked software. And both ARRL and CQ considers those invalid contacts. They require a human operator to initiate each and every contact. So hopefully nobody's using the hacked software here. And if they are, you know, just throw away any of your awards or certificates, because they're basically worthless. Or either that or send them into Microsoft.
Yeah, I agree.
Ken, I have a 6-meter skimmer up, listens to FT4, FT8 on several frequencies, and also meteor scatter on 6 meters. It's kind of interesting that there appears to be low-level sporadic-e pretty much continuously. It's rather rare that I'm not hearing a station in the 500 to 1,000 mile range on FT8. And that's pretty much continuous. They're not necessarily all that loud, but they're there.
That is true. But what I observed watching the chat page, the equinox period is still very bad for Sporadic-e, like September, October, March, and April. You still will have events, but it will not be daily. I have, in addition to ham radio, I do a lot of other things on digital ionosounds, like type that are located in Boulder, Colorado, and other places. So they capture the FOES, the critical frequency of Sporadic-e. And so certainly during the summertime, any weak openings will definitely be covered by FT8, no doubt about it. So it does fill in the gap to a good extent.
It's pretty amazing how well it hears. Things that you would never hear on the weak signal end of the band are pretty solid. I
That's
know
true.
that's not considered to be proper, but it's a way to work, people.
Yeah. Well, it is hard to work 100 countries by traditional means like CW and sideband. With FT8, it does become easier. I'm up to 97 by the traditional means, but it's going to be a little tougher to get the last 3 unless I get a good F2 cycle. So we'll have to see.
Ken,
So,
what are the best months for F2 when it occurs?
from late October into early March, when we had the terrific openings in cycle 23, it was relatively daily occurrence from November, December, and January. I would think every day I would point my antenna east and work a few stations in Europe most of the time. And then afternoon time, I would point to the west and work California. And on some occasion, we had an opening to Alaska. So to get the F2 level that we need, you have to have like 3 or 4 days of solar flux index exceeding 200 and the solar sunspot number being over 200 as well. So that's a good general rule. But the F2 can be quite fabulous. I worked a lot of stations while mobile, running, 20 or 30 watts and a mag mount whip on my car. So it can be pretty significant, and I'm really hoping we get that at the end of this year into early next year.
Hey, Ken, this is John
Yes.
W9JN. Most of us know what Aurora E is, but could you give us an explanation of your thoughts on that, please? Thank you.
Yeah, it occurs in the same level as Sporadic-e, and it's essentially a Aurora formation that's getting so strong that it actually becomes like a Sporadic-e opening. And I've only heard it a few times, but the times I heard it, the signals like on voice is like full fidelity. It's very incredible voice quality, sound wise. And it tends to happen more in the north, like your area in Canada. So it's usually a very intense Aurora opening that develops into a Sporadic-e opening. Aurora openings tend to be very broad formations, and then when the activity is so high, it becomes a very well-defined Aurora E type of thing. So generally occurs during very high sunspot years. So that's my best explanation.
Thank you.
Hi, Ken. This is Tim, N0TB. Thanks for coming on and talking to us today. I'm kind of a newbie on 6, and so I've never experienced, like these F2 openings that everybody talks about in cycle 23 and so on. But I think some of it probably has already been experienced. In February, for instance, I worked 2 stations in the Indian Ocean, Fox Radio and Free B9. And, I mean, this is, I don't think this is a Sporadic-e type thing. And, it's kind of exciting to see it starting like that. And you can't wait to see what happens, like this coming F2 season, but seems like it's kind of already started. Maybe FT8 and these digital modes have kind of allowed some of these weaker F2 openings to be taken advantage of, where they wouldn't have, and shorter F2 openings, you know, that you wouldn't normally see using the traditional modes like CWR sideband. Ken, what do you think?
Yeah, I agree with that. I think it has started already. It tends to be more equator based when it first starts up. So you start working these stations around the equator by these long path F2 opening. I'm going to give you a little story here. A lot of you may know of Aulus W0XU, originally from
Yep.
South Dakota. And he went to Easter Island, I think it was 2000, April 2000. And I was fortunate to work him on 6. I was actually at my work location. So I set up my 3-element beam in the parking lot up 15 feet, and I managed to work him. And when he came home, I had a discussion with him. He was telling me that he, from Easter Island, when he pointed the opposite direction of you normally would think of using, he was working into India by long path. And a lot of the stations from India were running very low power, like 10 watts. And he worked quite a few of them. And there are paths out there, F-layer paths, long path, which are waiting to be discovered in some ways. So that's my best answer about that.
Yeah, I mean, I can tell you that it's like I was aiming, you know, during this time. The FR and the 3B9, it was a direct path for me, but later on, you know, I was aiming towards South America, and you know, I was being decoded in the Canary Islands. You know, and so this is definitely not a direct path. I'm not exactly sure what was going on.
Yeah, that's for sure. My best DX on 6 was FR5DN from Reunion Island, and that was in October of 2011, I think it was. I gotta get my year straight. No, 2001. And that was also a parking lot experience. And you think about that distance from Long Island to Reunion Island, that's over 10,000 miles, right? F2, probably double hop F2, or if you want to call it double hop. But I think, like you see on 10 meters, you get some unusual paths in directions you don't expect. I think the same thing is on 6 meters. They have to be discovered, and with FT8 being able to go to the low audio range, I think more of that will come out over time.
Thanks, Ken.
Thank you. Any other questions?
Gordo here with an observation. I think one of you really hit the nail on the head, and that was the word excitement. So certainly we need to encourage young kids to see the what takes place with FT8, and you end up with a piece of paper saying, I've worked this many stations, but nothing beats the excitement of turning those kids on to actually hearing Aurora, actually hearing Sporadic-e, and the sounds that you hear before Sporadic-e opens on 6 meters. There's a distinctive, very low level sound. And many of you that have won some of the prestigious awards know what I'm talking to. You can almost tell by the sound that the band is soon to open. Yeah. So congratulations for all of you for being great DXers. But let's keep the word excitement in ham radio by making sure that the kids do more than just get on the computer, but start using their ears and turning up the volume and fishing for stations like the old-fashioned way.
Thank you, Gordon. Nice to hear from you.
Thank you.
Yeah, Ken, I have another. Ken, this is John W9J, and I have another question. You alluded to the fact that you had a low antenna in the parking lot at about 15 feet, and you were working some of the stations a long distance. That same station, if the antenna would have been like at 40 or 60 feet, do you feel that you would have had the same type of communication?
Yeah, it might have been a little easier to work on, that's for sure. But there's a lot of discussion about high angle and low angle radiation. Some of the guys on the ON4KST site, the fellow named Lefty K1TOL had two setups at different heights on his tower. I think they were at least 20 feet difference, maybe more. And that's when it gets to be a real art form, when you start hearing one station better on a lower antenna than the higher antenna. I don't profess to know a lot about it, but I know that's kind of what's involved there. I will admit 10 or 15 feet isn't particularly high, but it's usually more than enough to work, fairly strong Sporadic-e opening. When you get into other things like F2, you just pray for it and hope there's not a tremendous pile up. So yeah, there are differences in height, but I'm not going to get a 50-foot tower up in the parking lot.
Thank you.
RV here, Bill. One observation is that this season during around Trans-equatorial, we had an F2 link into the magnetic equator and side scatter into Africa through that. And that was a real interesting thing. And it was pretty broad. You could point from here, from California, you could point towards ZL or all the way over to VP8. And that's a pretty good swath here. And the signals are all the same strength. Plus, you can backscatter off the equator as well. The geomagnetic equator has an electron bulge there, and you can backscatter. We're backscattering back into the Caribbean from there. That was really interesting this year. Also, you mentioned -3 dB for CW. What bandwidth were you talking about with -3 dB?
Oh, I don't know specifically. I think I copied that, but I thought that was a rough number for like when human hearing can hear something -3 dB. Am I wrong, or is it a little bit higher than that?
Well, it has to be relative to something also, so
I see.
signal noise with 3 dB, -3 dB signal noise. The human brain can process a lot. Maybe you can hear signals below the noise. Plus, there's some regenerative things going on. Like for most CW offs, they'll copy, especially on 6 meters, they'll copy a couple of letters out of the call sign, then wait, and they'll come back up, they'll copy another. So if you're talking about -3 dB average, really there's peaks and valleys there. For FT8, what they report back is the signal to noise ratio in a 2.4 kilohertz bandwidth. So that would be equivalent to what the signal to noise ratio would be in a single sideband bandwidth. But if you drop down to 100 hertz, you pick up a lot, right? So typically, when you're about -12 or so in the reporting on FT8, that's when you can start copying it on CW. And I've done a lot of this. I've ran down the CW band when I copy stations at 0, which is really good, right? That's like what, 24 times higher than above the signal, the noise in the CW bandwidth. So I run there and I call CQ and nobody answers, of course. So it's been pretty frustrating that way. I think everybody's just parked on FT8 now, and it's a good thing. Day before yesterday, I worked 2 9K2 stations from the West Coast. I think it was the first time we had an opening to that area, and their signals are +4. One thing I'm going to say is that people are parked on FT8, so they see more openings. It's not just that it's a more sensitive mode. You're there, so you see it more often. It's increased the band population, and people are watching everywhere. So these openings might have occurred in previous cycles, but we don't see them because we're not there. That kind of thing. Whereas on FT8, you see everything in that bandwidth, and when it comes up.
Yeah, I agree. Although I think when people were pursuing DX prior to 2015, they would park on 50.110. But again, if it's weak signal, you may hear a part of a letter on CW, or you may not. So FT8, has a tremendous amount of improvement over that in terms of hearing a signal. So it has definitely changed thinking. Yeah, I agree.
Yeah, it's about 8 dB improvement. That's the improvement over it. And I worked the majority of my DXCC on 6 meters. In the back side of cycle was 23, and that was on phone and CW. And yeah, but it doesn't compare at all to the openings we have almost daily on FT8. And there are around Trans-equatorial season, we almost had, I think, up to 84 stations in South America per day. And they were there just about maybe every other day, I would say. About half the month they were there. It was just an incredible amount of time. In California, we've never copied a Northern European, but last season's season, there was just a huge opening to Northern Europe. So, and it was the digital mode, but again, their signals got up to, like one of the 9K2s yesterday got up to +7, which is huge. But the thing is, somebody has to be there to catch them, right, on other modes. So even on 5110, and a lot of guys in CW go down to 50.095 or something like that. But you'd have to be there. Now, I guess if you have a skimmer going, you could probably see them too, right? So you can pick up a large number of signals in a given bandwidth.
Exactly. You have to be there. So yeah, it has changed, has improved a lot for sure. So we'll have to see what happens coming up too. I like to see that when it gets over a certain level, people go to the modes like CW and sideband. But we'll see what happens. More questions.
One more aside is that the last season or 2 seasons ago, a Sugar Mike came in on FT8, and he moved 3L2 AG also did this. He moved to 50.300 and went on sideband, and a bunch of guys went down there and worked him on sideband. But that opening would have never been noticed had he not been on FT8.
Yeah, that's a good point. And also we do have the chat page, the ON4KST, which has been a good spotting, tool.
And PSK Reporter, which kind of gives you an idea.
Yep. Yeah. It's amazing what's out there that we didn't used to pick up. Another question.
Hey, Ken, this is Rick, NE8Z up here in Michigan now. You spoke about simple stations when F2 is really good. And in fact, I was just looking at my old logs here, HC8 VHF from 52 years ago. I ran 9 watts with a Belcon Liner 6, sideband only, from the Galapagos, the 2-element quad at 60 feet. And it worked pretty good for a few days. And then one day the wind blew the antenna down, bamboo pole. So I put it back up again at about 25 feet, and it really took off. So yes, height does matter. Here in Michigan, I have 2 antennas. I have a 5-element M squared at 27 feet. And then I have a 6-element LFA on the motorized tower, which I can raise up and down. And there are days that I can work into Europe with the 5-element at 27 feet, and I hear nothing on the 6-element at 45 feet. So, but that can change from day to day. It is good to have 2 antennas. But when F2 is here, and that was December 1981, with only 9 watts, I literally had all of the states. I had a lot of Europeans. That was back in the days when I would be on 6, but they would answer me on 28,885 because they didn't have 6-meter privileges.
Yes,
So it
I
was
remember that.
Yeah, it was a cross bands. But
Yes.
For those that haven't experienced the peak of a sunspot cycle, believe me, 10 watts in a little simple 3-element Yagi or 2-element quad at 25 feet, and you'll work the world for hours, hours and hours.
Absolutely. I'll give you another story. F2 is, when it's hot, is a very good form of propagation, but Sporadic-e is actually more efficient because the layers are metallic as versus oxygen for F2. That's just what I believe. You know, metallic layers reflect better, in my opinion. Don't know how I can prove that, but I went to Bermuda in 1999. I did take a license for me, but I was kind of limited to how much I could bring, and I needed a self-sufficient station. So I brought an FT690 in battery mode. So that's 2.5 watts, a mighty 2.5 watts. And I had a quarter wave whip that mounted right into the face of the radio. And I found a spot off a golf course overlooking the ocean. And there was a Sporadic-e going back into Northeast United States. And here I am. And so somebody called DX, CQ DX, and I answered, and next thing you know, I stole his frequency at 2.5 watts. So I worked about 8 or 9 stations during that opening, but that plus other experience showed me that Sporadic-e is a very, very efficient form of propagation when the layers get very solid and reflecting. But it varies a lot. That's the problem. It gets dense, it gets less dense. So we have some very amazing propagation modes on 6 meters and 10.
Ken, this is John, W9JN. Got another question about Sporadic-e. Of course, we all know what it is now and how it operates, but generally, what is the diameter of most clouds? Is there an average? Are they 50 miles wide or 100 miles, or do they shrink up in size? I know some of it falls to Earth, but what is the pattern as far as diameter, please?
They're typically about 200 miles in diameter, but it's not a neat, circle, but it's 200 miles wide. And they're always moving. So you hear the direction of the skip change subtly over time. So you may not hear one station anymore. You hear somebody further south to them as it moves. I have some plots in the book. And the formation itself will be like 5 or 6 grid squares at least, where it is. And then so you're on one side of the formation contacting to the other side. So while the layers are very thin, like they may be 1 kilometer thick, they might be 200 to 300 miles in rough diameter. So
thank you.
You're welcome.
If I can chime in to something that Rick said a few minutes ago, I've experimented with and actually made permanent antennas for 6 meters from 20 feet high to about 65 feet high. And it is dramatic, the difference you see with the different height antennas.
Absolutely.
It probably changes too, each opening you have. You have to try both and see which one's going to do it.
Oh yeah, one's not better than the other. I mean, it all depends on the propagation angles, I guess. But and sometimes it changes. It'll move from the 20 foot to the 40 foot to the 50 foot to the 20 foot and then up to the 65. It's somewhat random, but it's amazing what you can do with a 20-foot high antenna.
Yeah.
The lowest station that I ever worked, this is going back to CQ VHF days, was a guy in Michigan. It was on 50110 sideband. He was in the pileup. He wasn't that strong, but I could hear him. And he made a comment to me. I'm in my basement and I'm running 1 watt with a clothes hanger jammed into an SO239 that was on his bench vise. And I could copy him, no problem.
Yeah, that's a good opening.
That's a good opening.
One thing to consider, when signals go up to the F layer or E layer, they're rotating, the Faraday effect. So along with that, there may be other characteristics that come out with different antenna heights. You know, your takeoff angle, sometimes there may be an impediment or something that helps your signal, but it may all be dependent on height. I wouldn't profess to know the magic formula, but I do know people observe different things like you have pointed out tonight, different heights. So
my antenna right now in Ecuador, I'm down there 6 months of the year now. So I'll be back in October. I've got a 5-element LFA at it's 100 feet above the ocean. I'm about a block and a half back from the ocean. And sometimes I know that that antenna is too high, but I really can't put anything lower. I would love to put a 25-footer right next to the ocean. There'd probably be a huge difference. But there are times when the band is open, Sporadic-e, my screen turns orange. A lot of guys will say, why didn't you answer me? It's like, I have a total orange screen, and it's like, who do you pick, you know?
Yeah.
And in cases like that, sometimes I'll even lower my power. Most of the time I'll run 100 watts. I can run 500. But usually if I lower the power to 10, 15 watts, the screen still stays orange. The band's open, the band's open. If it's not open, you're just not going to get anything, no matter how much power you have.
Yeah. Yeah. Well, that's a big point about 6 meters. It is propagation dependent.
Mm-hmm.
You know, it's one thing to do 5-band DXCC because 80 and 40, you can kind of like pick your times to work certain stations. And 10 meters, it's more or less sunspot dependent, you know, the peak years. 6, you're like totally dependent on propagation to work 100 countries. So any more questions? If anybody has any questions they're thinking of, they can always send it to me by email, you know, ken.neubeck@gmail.com. It's also on QRZ. So if you have any questions or observations, you know, please send me an email. I want to thank everyone for coming tonight. I want to thank the club for allowing me to speak. I hope, you know, it sounds like we had a good discussion about different parts of 6 meters. So I hope it worked out for everybody here tonight. And I want to thank you all.
Ken, we're going to thank you. Great presentation. The discussion after the presentation was fascinating. And I appreciate everyone coming up with their questions and observations. And Ken, the way you shined light on those questions and discussions was invaluable. So thanks, everyone. Everyone have a good evening.